Hello everyone, hope you all are doing well. So in this video, we'll discuss the second problem of Leetcode Weekly Contest 37. It's a medium level problem, but yeah, the what you want to solve is exactly similar to what was asked in the first problem. So it's all the same problem statement, but yeah, the configuration or rather the input format is different. Okay, there you had a grid, here you have a DAG. Okay, but yeah, let's see. If you're coming to this video directly without watching that video, no need to worry, we'll be starting from the basics. So the problem name is find champion 2. So it says that there are n teams numbered from 0 to n minus 1 in a tournament. Each team is also a node in a DAG. What is DAG? Directed acyclic graph. We'll see that afterwards, don't worry. Now you are given the integer n and a 0 index 2D integer array edges of length m. Okay, so basically they are part of the DAG, right? Now edges of I is basically ui comma vi, indicating that there is a directed edge from ui to vi. Okay, simple. How this is how the input is given. Now what's the meaning of the input? A directed edge from A to B in the graph means that team A is stronger than team B and team B is weaker than team A. Okay, if it is like this guy is stronger than this guy. Simple. Now team A will be the champion of the tournament if there is no team B that is stronger than team A. Okay, exactly the same problem statement. Return the team that will be the champion of the tournament if there is a unique champion, otherwise return -1. This is an additional constraint that we have here. Okay, now notes. A cycle is a series of nodes a1 a2 till an plus 1 such that a1 is the same node as an plus 1. Okay, it is like this. Okay, you go like this and then you have like this. So this is a cycle, and since this is a directed graph, it's a directed graph and you have a cycle. Now in case you have a directed graph and you do not have a cyclic, so it's known as acyclic graph. So a directed acyclic graph is a directed graph that does not have a cycle. This is a cycle, and in a directed graph you do not have a cycle, it's known as a DAG. That makes the problem very easy, right? Simple. So in short, let me come what the problem is saying. It says that look, you have three teams. In this example, you have three teams and you are given some edges, right? It is like this. 0 points to 1, 1 points to 2. You have to tell the winner. Okay. Now what does this mean? This means that 0 is stronger than team 1 and team 1 is stronger than team 2. Okay. Sorry, you have to tell the champion. Which team is the champion? A team is champion if there is no other team stronger than this team. Simple. So again, let me follow the same approach that I used in that video, but we'll start from the basics. Just see, you have three nodes, right? So initially all of the nodes are your candidates for the champion. So 0 can also be a champion, 1 can also be a champion, 2 can also be a champion, right? Now again, we are coming up with the intuition, right? We are not jumping to the solution, rather we are discussing the intuition here. Okay, initially all three are your candidates. Now the first edge is 0 to 1. 0 to 1, it means that team number 0 is stronger than team number 1. Now consider team number 1. Because of this edge, 0 is stronger than 1, so 1 cannot be my champion, right? Because there is at least one team is stronger than team number 1. Okay, and which team is a champion? Right, a team is champion if there is no other team stronger than that team, right? But in this case we saw that 1 is weaker than 0, so 1 cannot be my champion, right? So this set which tells you what are your candidates, you will remove 1 from here. Why? Because 0 to 1, 1 is weaker, so 1 cannot be a champion. Simply remove 1, right? We'll keep on eliminating the teams like this, right? Now what is the second edge? It is 1 to 2. What does this mean? This means that 1 is stronger than 2. That means 2 cannot be my champion because 2 has at least one team stronger than itself. Remove 2 as well, right? There are only two edges here. What are you left with? You are left with just one team here. So 0 is that team and hence 0 is your answer. Remember, for this example, you were left with only a single element, but there can be cases where you get more than one element, right? So no need to worry about that, right? Let's see this one. Sorry. Initially your candidates are 0, team number 1, team number 2 and team number 3. Now let's go with edges. 0 comma 2. So that means 0 is stronger than 2. So 2 cannot be my champion. 1 3. So 1 is stronger than 3. 3 cannot be my champion. 1 2. Right? So 1 is stronger than 2. 2 cannot be my champion. Okay, I've removed it. Now after processing all these three edges, what do I get? I get that that these are the two possible teams that are champion, right? But the problem says that return the team that will be the champion of the tournament if there is a unique champion. Otherwise, return -1. Now, just see, my friends, what happens. Here you have two champions. So, what you will do, you will return -1. Okay, 0 is also a champion, 1 is also a champion. So, you return -1, right? So, this is how you'll approach this problem. Just try eliminating the things, right? No need to actually construct the graph. Just use the information given in the question, right? Just see the constraints are very low here. But even if the constraints were not low, you would have, the same solution would have worked. Why? Because what we are doing, we are just traversing the edges, right? Now obviously the input will be given which with constraints such that you are able to traverse all the edges, right? They cannot give you 10 raised to power 9 edges. It's not feasible, right? They will give you the edges such that you are at least able to traverse those edges. Now as soon as you traverse those edges, you are doing a couple of operations, or rather just one operation. That is a big of one operation. What operation? Removing an element from a set. Simple. Okay, so there is no issues with that. Let me just show you the solution. It's almost similar to the first problem. The only difference is here you have what do you call it, edges. There you had a grid. Okay, let me show you the solution. This is these are the candidates, right? This is the set which contains my candidate. So initially every team is my candidate, right? So just see, I'm adding all the teams from 0 to n. Now let's come here. What are we doing? This is, so traverse all the edges x, y. Now just see x, y. So there is an edge from x to y. So y cannot be my champion. So remove y from the set. Simple. Now the last check. Sorry. Teams dot size is not equals to 1. So look, if I have more than one champion or I do not have any champion, whatever is the case, I simply have to return -1. Else what I have to do, there is a single element, right? I take the iterator, I get the single element from the set and I simply return it. All right, no need to construct the graph. And if I talk about the accuracy of this problem, I see that roughly 50% of the solutions have failed. So the core reason could be this one. Most of the people might have missed this, right? Because in this example also we saw that we have multiple teams. So in this case you need to return -1 and not 0 or 1. Okay, that's what we need to do. So yeah, that's it for the solution. I hope you learned something new from this video. Please do support it by giving up a thumbs up. Do subscribe to the channel as well. In case you have any queries related to the solution, please mention that in the comment section. I'll revert on each one of them. And in case you used, like you had some other thought process, you used any other method to solve this problem, mention that approach in the comment section so that it's helpful for everyone else, right? Because you can have multiple ways to solve the same questions, right? So yeah, I'll see you in the next video. Take care. Bye-bye.